All right, so in this video, we're going to be testing a model that describes the relation between the dependent variables and explanatory variables by means of ordinary least squares regression. We already did that. It's important that the assumptions of the classical linear regression model, the Gauss-Markov assumptions, are respected. So these assumptions, let me open up the notebook. So for these assumptions, the expected value of the error term has to be 0. There has to be 0 covariance between our explanatory variable, which would be log stock to flow ratio, and the error term has to be 0. It has to be homoscedastic, so it has to have a constant variance, not conditional on log stock to flow or not conditional on time. And then there has to be 0 autocorrelation. So these are the four main assumptions. So let's start with the first one. In order to check that the expected value of the error term is 0, we're going to calculate the mean of the regression residuals, and we're going to conduct an hypothesis test for a single mean for a 5% significance level. Before we do that, let's start with a plot. To get the residuals, what makes the residuals, or some of it is a little bit different than the predicted value. To get the residuals, it's just reg.resid. To get the predicted, you have to do the parentheses. But anyway, let's do a distribution plot of the regression residuals. Here we go. This looks fairly normal. It looks pretty centered around mean. Let's calculate the mean. So reg.resid gives us an array, one-dimensional array. Let's calculate the mean. And this gives us 1.16 multiplied by 10 to the power of negative 15. So this is a very small number. Whenever you go to do your test or your test, the null hypothesis would be that it is equal to 0. The alternative hypothesis would be that it is not. So you would divide this by the standard error, and this is going to be a very small number. So for the standard error, to get the n, the size, we do reg dot number of observations, open close. This gives us, I'm sorry, maybe not open close, right? So this gives us 114. So this is our n. So n is equal to reg dot number of observations. So whenever you do this for your t-stat would just be the mean divided by the square root of or the variance divided by the number of observations. Whenever you go to do that, to get your t-stat for the hypothesis test, we're going to use SciPy stats. So SciPy stats, you get statistical functions, and t distribution is continuous. So these are all continuous distributions, and it would be t right here. So to get the t-stat, we'll do SciPy.stats.t. Let's do ppf. This is the percent point function. I'll go over here and we'll see it right here. So for the percent point function right here, you give it q, or the percentile. So it's the inverse of the CDF. You give it your probability value. So you give it maybe 0.95 for 5 or 0.975 for a two-tailed for a two-tailed 5% significance level, and then give it the degrees of freedom, and they'll output that t-stat, what you would see in that, or the critical t value, what you would see in the in your t table from your econometrics class. So let's give it q to 7.5, and the degrees of freedom would be n, which would be the regression number of observations, minus 1. So there's degrees of freedom would be the degrees of freedom that this number could be. You know, it has to, you know what the one option would be the, I mean, anyway, we already talked or went over all the degrees of freedom in the previous semester. Okay, so this, you'll do the hypothesis test, and you will fail to reject the null hypothesis. So the first assumption is met. So this is this checks out. The next video will cover the correlation and the second assumption.